Okay, so first in our 5-part series about multiple dosing, the model that we're going to be using is the bolus model. This makes it a little more simple than if you were dealing with like an oral dosing model or an extravascular dosing, because with the bolus model, you're going to have rapid absorption, and then it's going to decay. Okay, the initial concentration is SFD over V, where S is the salt factor, F is bioavailability, D is your dose, and then V is your volume of distribution. If you wanted to figure out the concentration at any point along this curve, all you have to do is multiply C naught. Okay, so we're going to say C equals C naught times e to the negative kt, where k is our rate constant of elimination and t is the time along this curve. Now, what you want to do with multiple dosing is think about it as a bunch of successive bolus doses. Okay, so we're going to go up, decay a little, go up again, decay a little, go up, and decay a little. Okay, so in this graph that I just drew, we did 3 doses, 1, 2, and 3. And the time between each dose is going to be this variable tau. Okay, tau is going to be fixed, and it's just going to be, you're going to design this in your little dosing regimen. So what can be a little complex about multiple dosing is you got to find out what your starting point is for each given interval. Okay, so like the peak is going to be C2 max, and then the trough, okay, like your minimum is going to be C2 minimum. Okay, thankfully on the final we are getting an equation sheet, and the most important equation you're going to use for multiple dosing is going to be Cn equals SFD over V times 1 minus e to the negative nk tau divided by 1 minus e to the negative k tau. Okay, the only variable that's unfamiliar in this ratio is going to be n, and n is just, are you dealing with the first dose, second dose, or third dose? Okay, so we have an equation with the first term dealing with dose. The second term is going to talk about accumulation. Okay, it's going to measure how much of the drug is accumulating, because what we're doing here is we're dosing it before the body gets rid of all the drug. And there's going to be a third term in this equation, e to the negative kt. Take notice that I put t instead of tau, because this is not the dosing interval. This is going to be the time t after you administer the medication. Okay, so the concentration of the dose times the accumulation, this is actually going to be Cn max, and then that final term is going to be talking about how much of that drug decayed inside your body. Okay, now the last thing that I want to make sure that you understand is the difference between t and tau. Okay, so t versus tau. As I said before, tau is your dosing interval, and this is going to be fixed. Okay, so this is like when you say, hey, the drug is administered every 8 hours. That does not change. T is going to be the time after dose administration. Okay, so it would be someplace along the curve for a given interval. For example, we could say that we are dealing with what is the concentration at this time t. Okay, this time t is after the second dose is administered. Okay, and it follows then that your Cn max is when t is equal to 0. Okay, because when t equals 0, no decay has occurred. And then Cn minimum is going to be when t equals tau. Okay, because when t equals tau, you're at the minimum and you're about to administer the next dose.